Okay, so we're running this a second time. And if you're done, if you're over it, you can stop, okay? But you've got your free body diagram. You've got, it's helpful to have that other little triangle where you don't have all the forces on top of it. And we're going to find the ratio using sum of forces on the x-axis. So we know that that's 0. And we also know that that's equal to all the forces pulling that thing to the right and all the forces pulling it back to the left. Okay, we're going to skip a few steps because we're going through this the second time. So we can set those equal. We know that 0 equals, well, the only force we have to the right is force of tension x2, and the only force we have to the left is force of tension x1. So we know that those must be equal to one another in magnitude. So ftx2 equals ftx1. And they're opposite. We'll get to that. Here we're just dealing with magnitude right now. Okay. So we're going to go ahead and put in our expressions for those. We know that this is equal to force of tension 2 times cosine theta 2. And we know that force of tension 1 cosine theta 1 is going to be our force of tension on the x for side 1. This is the easy part, right? This is okay? We're good with this. And by now you are so good at breaking those vectors down that you could do that in your sleep. If I woke you up after 4 hours of sleep and only a cup and a half of coffee, you could do the vector resolution. Okay. Well, let's look at the relationships we've got that we can use. So we have this ft1 equals 2 times ft2. So we're going to go ahead and make a substitution. And we end up with ft2 cosine theta 2 equals, 2 ft2 cosine theta 1. And you know what? We're going to skip that whole 90 minus business because there's a more streamlined way to do that. Okay. Well, at this point, we can actually cancel out our ft2 because we really don't care. We're going to find force of tension on the other axis because that's where we have gravity to sort of compare it to. So we can just cancel those out. And what we have for our next step is cosine theta 2 equals 2 times cosine theta 1. Okay. Well, the funny thing is that if we look at this triangle right here, we have some relationships. We can list these. I mean, this is pretty basic trig stuff. Sine theta 1 equals b over h. Sine theta 2 equals a over h. So then for the other angle, or I'm sorry, for the other trig functions, well, the cosine of theta 1 equals a over h, and the cosine of theta 2 equals b over h. Hey, looky there. We have these two things that are in fact equal to one another. Oh. Well, that makes life a little easier, doesn't it? Well, what if we then said, okay, fine, the cosine of theta 1 would equal the sine of theta 2. I'm going to shrink all this. So cosine theta 2 equals 2 times sine theta 1. What if we divide both sides by 2? Well, okay. Yeah.
Why sine of theta 1?
Because I wrote the wrong angle. Theta 2, sorry. There, sorry. More coffee. More coffee. Okay. So if I divide both sides by 2, I now have cosine theta 2 divided by 2 equals sine theta 1. Well, what if I divide both sides by cosine theta 2? I now have 1/2 equals sine theta 2 over cosine theta 2, which is tangent, which means I have a single number that I can use an inverse tangent function with. So we can say that 1/2 equals tan theta 2, so the inverse tangent of 1/2 equals theta 2. Now, is it easier the second time through? Does it make more sense? I left out that whole 90 minus theta thing. Sorry about that. Here's the real thing that you want to hear. I'm not giving you one of these on a test. That would be insane. That would be stupid. You'd spend more time trying to find your angles than you would do in the physics. And I'm more concerned with you being able to do the forces and do the sum of forces than I am with you being able to do. I mean, this is fun. This is like great recreational stuff. I would do this on a Saturday morning, but because I'm sick. But you know, it's not the key thing here. So it's a good mental exercise. It's good for you to be able to do this sort of. This is analytical geometry. This is straight up analytical geometry. Good for you to be able to do it. Not the thing I want to test you on. So if you have a cable problem with 2 different tensions in the cable, you're going to get the tensions, or you're going to get the angles. I'm not giving you analytical geometry tests, okay? With the angles, can you proceed from there and finish number 5 on your own? Wunderbar. So do that, and then I'll have you go ahead. Some of you, I think, already did while we were doing this. I'll have you turn those homework problems in, and we'll go ahead and FIP. It's only 3 problems. I think you can do that in 1 period, even if it's a half hour. So 10 minutes per problem is ample, I think. Okay, that's it. Yeah.